welcome to my YouTube channel. Today I'm going to take you through longitudes and time. And if you didn't check, our previous video was about calculating distance in kilometers and nautical miles, of which you can get those videos on this link up here. So for instance, today I have a prop for you. You can see we are going to use this basketball as our earth, and then these ships as our longitudes. We have this longitude will receive the sun earlier as compared to this longitude. So as the earth rotates, this longitude receives the sun, and then this one. So the longitude that are on the east, they receive the sun rays faster or earlier as compared to those on the west. So to begin with, so we know that the earth takes 24 hours to go around the sun. So the earth takes 24 hours to go around the sun, and that rotation is equivalent to 360 turn. So we know that the earth takes 24 hours to go around 360 degrees. Have you ever asked yourself how long does 1 hour takes for the earth to rotate? Have you ever asked yourself how long does 1 degree takes for the earth to rotate it? So we know that. So if we're going to ask ourselves if 24 hours is equivalent to 360 degrees, have you ever asked yourself what about 1 degree is equivalent to what? So this we're going to cross multiply. We're going to say this is equivalent to 24 hours times 1 degree over 360 degrees. So let's change these hours into minutes. So it will be 24 hours multiplied by 60 times 1 degree over 360 degrees. So this one, it's in minutes. So this degree will cancel with this one, and then 0 will cancel with this, and then by 6 you're going to get 6. By 6 we're going to get 1, and by 6 we're going to get 1, by 6 we're going to get 4. So this is equivalent to 4 minutes. So it means that when the earth rotates, or the distance, the difference in minutes between one longitude, this distance in minute, it's 4 minutes. So it takes 1 minute for the earth to rotate to one longitude. Are we together? So for instance, we can see this is our Greenwich meridian of the center, and this is our first degree. So when the sun rotates, when the earth, the light rays are from this side. So this means that our A will receive the sun rays 4 minutes earlier than B, and B will receive sun rays 4 minutes earlier than C, and then C will receive the sun rays 4 minutes earlier than D, and D will receive the sun rays 4 minutes earlier than the Greenwich meridian. So those longitudes on the east, or on the right side of the longitudes, they receive the sun rays 4 minutes earlier. So when you are told that the Greenwich meridian received the sun rays at 8:40 a.m. So it means that our D here received the sun at what time? 4 minutes earlier. It means it received the sun 8:36 a.m. So if B received the sun 8:36 a.m., it means that C, so this is our D, it means that C received the sun rays 4 minutes earlier, which is 8:32 a.m. Same applied. If C received the sun rays at 8:32, it means that B received the sun rays at 8:28 a.m. So the longitudes on the east receive the sun rays 4 minutes earlier, or the longitudes on the right hand side receive 4 minutes earlier the sun rays, because one degree it's equivalent to 4 minutes. Are we together? So it's two terms S and T are On the longitudes 28 degrees west and 42 degrees east respectively. Which town will experience a daylight earlier and by how long? So when you have this one, they've said that two town S and T, they are 42 degrees west and 42 degrees east respectively. So we're going to draw our Greenwich meridian here. This is our Greenwich meridian, and then we have from here to that point it's 42 degrees east of the Greenwich meridian, and then we have the other one, it's on the west of the Greenwich meridian. This is our zero, it's 28 degrees to the west. So this marks our S, this marks our T. The question is which town experienced daylight early and by how long? So first we know that T is ahead of S by how many degrees? T is ahead of S by how many degrees? You're going to get the angle difference. You're going to get, it will be 28 from here to here, it's 28 plus from here to here, it's 42 degrees. The total is going to give us, what is the total? 28 plus 42 is going to give us 70 degrees. So it means that T, it's ahead of S by 70 degrees. But remember what we said. Remember what we said back here. Remember what we said back here. We said 1 degree is equivalent to 4 minutes. Meaning that our 70 degrees will be if 1 degree is equivalent to 4 minutes. What about the 70 degrees? So this will be 70 times 4 minutes. This is 70 degrees over 1 degree. So this degree will cancel with this one. So it will be 4 times 70 minutes. This will give us 280 minutes. So T will receive the sun rays to 80 minutes earlier than 28 minutes earlier than S. But let's change this to 280 minutes into hours. We're going to change it by this way. We're going to divide 280 minutes by 60. So it will be 280 divided by our 60. We're going to get 240 because of 4. For this, subtract to this, you're going to get 40 minutes. 40, the remaining. So we are going to say that T receives the sun rays, receive the sun 4 hours and 40 minutes early than S. Are we together? And you can take it from the top how you've done it up to our answer. We're going to move to our second example. Two towns P and Q are both on the equator such that Q is due east of P. When the local time in P is 8:30 a.m., the local time in Q is 2:40. Calculate A, the longitude difference between P and Q. B, the distance between the two, the town in nautical miles. But first we're going to sketch this on this table. They've said that two towns P and they are located on the equator and such that Q is due east of P. So we are going to draw. I'm going to draw for you. I'm going to say this is 0, this Greenwich meridian. Then we have our equator. We have our equator here. So they've said what? They've said such that Q is due east of P. So Q is somewhere here. But P is on somewhere along any place along this area. Are we together? We can assume it's here, we can assume it's here, but because P, they say Q is due east of P, so it means that P is due west of Q, so we can put Q there. Are we together? But first we're going to locate the point of P. They've said that the local time in P is 8. In P, let's use this P. The local time of P is 8:30. So we have P here, and then we have Q here. So here it's 8:30, and then 8:30 a.m. and then P it's 2:10 p.m. So first, the first thing here we're going to, because we've been given hours, we're going to find the difference in minutes. So by first, we're going to change this in 24 hours. It will be 14:10 hours, and then this one will be, so this is our Q, and P it will be 08:30 hours. So difference, you're going to subtract. So this subtracted, we are going to borrow here 1 is going to be plus 60. So 70 minus 30, you're going to get 40. And then here is going to, you're going to be left by 13. 13 subtracted to 8, you're going to get what? 5. So you have 5. So 0, 5. So Q, the difference in time between these two, it's 0, 5, 40 hours. But we're going to change this because the first question they have asked, the longitude difference between this P and Q. The longitude difference. But remember, 1 degree is equivalent to 4 minutes. What about 5 hours and 40 minutes? We're going to change this 5 hours into minutes. So it's 5 multiplied by 60, which is going to give us 300 minutes. 300 minutes added to 40 minutes. So it will be 1 degree is equivalent to 4 minutes. What about 340 minutes? This will be 340 times 1 degree over 4 minutes. And this is minutes. So this minutes will cancel this. So 340 divided by 340 divided by 4, it's going to give us 85 degrees. So the first question we've answered, the longitude difference. So Q it's ahead of P by 85 degrees. So it means that Q it's 85 degrees east of P. Are we together? So you're going to move the distance between the town in nautical miles. So for the distance between the town in nautical miles, the distance, remember they've said it's the equator. This is our equator. So remember an equator is a great circle. So the distance between the two towns in nautical miles, we know that for the great circle, so for the great circle, we know the formula is 60 multiplied by the angle difference. This will be 60 multiplied by 85 degrees. This is going to give us 60 multiplied by 85 is going to give us 5,100 nautical miles. And there you have it. So remember this calculation distance in great circle in nautical mile. You can click on the link up here to check it. So there we have it, and that marks the end of our longitudes and times. So thank you for watching, and stay tuned for our next video.